old. So maybe we don't have them mastered yet. Okay? Maybe we don't have them mastered yet. Make sure the volume's turned up on my phone, sorry. Maybe we don't have them mastered yet, but we've seen most of these before. However, there are formulas, and sadly in Chapter 5, especially sections 5.4, 5.5, and 5.6, more formulas are coming. Nothing as big as this page, all at once. But there are going to be more formulas coming. Now, what's the dilemma in math when you have a section, no, I should say a chapter with lots of formulas? Memorizing them. Now, this is way back in like Math 6, Math 7, pre-algebra, when you were learning like little area formulas, right? Or volume formulas. Maybe you had to memorize those for tests. Geometry, you had like postulates and corollaries and theorems and all this stuff that you had to learn how to use, and some formulas were involved in there. Algebra 2, oh, well, yeah, you had formulas in there as well. So you guys know the dilemma is memorizing. Now, I'm just going to help you look forward to the future just a bit. The Chapter 5 test is going to be, I don't know, it's on the calendar, maybe in like 3 weeks. We have like a 5.1, 5.2 quiz before that, because there's a lot going on in 5.1, 5.2. I know, you can get your size out, but think Chapter 5 test. Oh, if you have to have all of these formulas memorized, have to remember them, and then use them, how brutal is that test going to be?
Very brutal.
Very brutal, unless a certain teacher decided, that's a lot to test on one day. What if we split it up? So, the test on this one is actually going to kind of be on 2 days. Really, one day is going to be, actually 2 days of review. One day is going to be, I think the first or second day of the review. We're going to have a formula portion to the test. I'm letting you know now because some of you need to start Quizletting this. You need to start formula carding this. You need to start flashcarding this. Whatever works for you. Reading it over, saying it out loud, writing it. But I'm going to have, it's literally, I think it's one side, one full sheet, and there's about 30 fill-ins. Maybe 25 to 30 fill-ins. Literally, just, I give you one side of the formula. The left side, I can tell you that much. I'll give you the left side of the formula, and you give me the right side. And I'll give you even the categories so that you know, like for the quotient, make tangent sine over cosine. For the reciprocal, make tangent 1 over cotangent. And you have to not only remember the trig, but you also have to remember like the u's or the x's or whatever variable you want to use. Well, you'll probably use the one I write. So on one day, there's going to be a formula portion, but the nice thing is, that's just memorization, which some of you do really well, and some of you, you're going to have to work at it. And that's okay, you know now, from day one, you have to have these memorized for that portion. But the next day, or maybe if I have like an in-between review day, when the next part of the test comes, it's going to be all problems, but guess what I'm going to give you? A printout of all the formulas. Sound good? So, why am I telling you this now? When you go to do homework, do you need to stress about trying to remember these formulas without using your notes? No. No. Because when you get to the problem portion of the test, you're going to have the formulas to be able to use. So if I were you, maybe even start making your own formula sheet. And that way you can have that and use that sheet on every single homework assignment, and you're getting used to having the formulas, using the formulas, knowing where they are on the paper, etc. So as you guys are writing them down, I wanted to give you perspective. I wanted to let you know what's coming. Yes, you're going to have these memorized, but you're not going to have them memorized and do problems all at once, only one day on the part of the test, or on the entire test. It's going to be split into 2. Filling in, basically, most of the formulas. Like, I might not give you all 6 of the cofunction. That's kind of silly. I'll probably pick 2. But I'll give you guys more details as that gets closer as far as, okay, maybe a couple of these, one of these, that category, forget that altogether. But you are going to have these memorized, but when the problems come, you're allowed to use a sheet that has all the formulas on it, so please in homework have the formulas nearby, that way you don't basically overtax your brain. Sound good? Okay. So there are going to be a lot of formulas. Well, these ones are mostly review, but we're writing them all down to say, hey, let's start here. Then we're going to learn how to use these formulas, apply them different ways in 5.1, 5.2, and 5.15. And then when 5, 4, 5, 5, 5, 6 come, we're going to see some other formulas, like the double angle formulas, half angle formulas, sum and difference formulas, different things like that. Okay? Oh, you guys are still writing? Ooh. Never mind. Dramatic pause. Not really dramatic. I'll just sit with this. Those of you that can multitask to break the awkward silence, any good presents? Any fun things you got?
Board game.
Which one?
Escape Room, the board game.
I've seen that, I haven't played it.
It's a lot of fun.
Is it good?
How do you play?
Do you know what the escape room is?
I don't know what escape rooms are.
It's that, but in a board game.
Oh, so you're trying to like figure out the clues,
Solve
or,
it.
but you're just not in the room itself.
Yeah.
Oh, that's actually.
Has anybody done this escape room?
Ah,
That's it?
I have. It was so much
Figured it out?
fun. We got
Oh,
out.
you did.
Yeah, we got
Yeah, we got out.
Try hard.
That makes sense, the game.
I told the guy running the game that I loved him, and then he gave me a random extra point. Or he gave me an extra
It's
point.
disturbing.
With both of you.
No,
Gotcha.
Any other good presents
I was
besides
saying how I
escape room,
hated him, and then he gave me the money.
Money? Money's good.
Oh, I got lots of
that. So.
Anybody else get gift cards? Cash?
I-
Check?
Hey Nathan, what'd you get?
They chose one.
He got a ton of quality.
You got a girl.
Sometimes like, without one hand. Yeah, exactly.
David. You got to go.
That's it. I got a math shirt. I was kind of excited. That wasn't all. I'm just kidding. But I had this one nerdy uncle like gave me like a math ornament, some weapons of math instruction instead of destruction, and had like protractors and stuff. And the shirt was I ate some pie. Have you guys seen that one? I ate some pie and really liked it. With a square root of -1. Why is that I?
Because it's imaginary.
It's imaginary. And then at number 8, that one's easy. 8 instead of 8. And then sum. How do you denote sum? S-U-M.
This line.
Yeah, the
Yeah.
sigma. Have you guys seen that on your SAT math?
Yeah.
Like this summation notation technically is what we call it. We haven't reviewed it this year. I think you saw it last year. Oh, you saw it. And then just pi. Those are my nerdy ones. Oh, and then like the one nerdy aunt gave me this huge stuffed gorilla. I was like, oh.
Nope, dead mean. Dead mean.
These do lots of random. Like I got socks. I got like lotion. Okay. One random stuff. They just like getting a laugh. So they like my mom, or I got like this cat that like does this BBS to Christmas songs. It's like okay. It's those ants. Does anybody have ants like that? Just like the weird. Or moms or dads. Yeah.
My great aunt gave all my sisters olives for Christmas.
Olives?
Olives.
Good.
I don't know.
They were probably cans.
They're in a jar.
All right, who's writing now? We're bound to. Oh my goodness.
Sorry.
We're close.
Stop talking.
All right. Section 5.1. They were the ones writing. Okay, section 5.1. Before we start, basically, long story short, this section, the directions say exactly what math you need to use. Now, a few might be general, vague, and a little bit ambiguous, so you have to kind of read into it. But for the most part, they're telling you what to do. The problem is, almost all of them have an inferred implied, or directly stated, simplified, using the properties. The struggle with 5.1 is they're going to tell you what math you're supposed to use, but they're not going to tell you exactly what the answer is supposed to look like, so you're not going to know exactly when to stop. But that's what the back of the book is for, especially with the odds. In section 5.1, it's going to be hard to know exactly when you've gotten to the answer, because the answer could look different ways. I just want to let you know that now. In section 5.2, they no longer tell you what math to do. You have to figure it out from what you learn in 5.1, but they're going to tell you the answer you have to get to. Let's go see the first one. Oh, this was just like a little reminder. Hold on. One quick reminder before we get to examples. Okay? Pythagorean identities. Someone give me the easiest, the most basic Pythagorean identity from what you just wrote down. Is it cosine first or sine?
Sine.
Sine. Sine squared of, did I use u on the other page? Plus cosine squared of u equals,
1.
what do I mean by rearranged? Does that sound like plugging in, or does that sound like moving around? Huh. Well, how do we move around stuff in algebra or math?
Equation.
Yeah, equations. How do I move stuff in equations? Well, I use stuff like, well, if it's addition, I can make it subtraction of the other side, or to the other side, right? So we could subtract the cosine squared. Let me not write the equals, that's awkward. Subtract the cosine squared. So one rearrangement, and I'm going to name this one like instead of, I think on the other page, you guys number them like 1, 2, and 3? Maybe not. Let's call this Pythagorean property 1a. This could be sine squared of u is equal to 1 minus cosine squared of u. Now what could be another rearrangement? What's another way of rearranging that?
Cosine squared of u equals 1 minus sine squared of u.
Cosine squared of u equals 1 minus. And if you guys can follow the logic, Caleb's saying, all right, instead of subtracting the cosine squared, let's subtract that sine squared. Okay. Are there any other rearrangements? I guess we could do the awkward sine squared u plus cosine squared u minus 1 is 0, but that just kind of doesn't sound very fun. Now, if I can rearrange this one property to look these two different ways, what can I do to the, or another Pythagorean property, what could I do to the secant squared, tangent squared u plus 1 is secant squared? What could I do with that one? I could rearrange. How about the cotangent squared u plus 1? I could rearrange that one as well. Why am I trying to show you this? Because if we're going to be using those identities to be plugging in, I just wanted to let you know, hey, we could also, instead of plugging in for sine squared u plus cosine squared u and having to have all of that, we could also just plug in for sine squared u, and I still have something to plug in for. Okay? All right, here we go. Problem number 1. Factor. Or example, I should say, number 1. Factor. They tell us the math. They give us an expression. It has trig, and an understood direction is and simplify if possible. Factor, and simplify as possible. Why are they saying factor? There's a squared. There's a squared on the left, there's a single in the middle, and there's a constant at the end. What does that sound like?
Nothing.
Ax squared plus bx plus c. It sounds an awful lot like the standard form of a quadratic, but what's in there instead of an x or a t or a u or an m? A cosine. So how do we do that? Some of you might like rewriting this as, possibly, 6u squared plus 5u minus 6. Well, how can you do that? Well, I just said, well, okay, it's something squared. And in math, we can always replace something with a variable, right? Now, who is the something in this case? Maybe we should state that over here. Who is u? Cosine. He's taking the place of cosine. Remember, cosine squared of x is the same thing as cosine x times cosine x. This is just a snazzy notation. Or some of you might just want to leave it the exact same and be like, no, I got this, I can deal with it. Now, here's the problem. However you look at this problem, whether you leave it with the cosine in there, or whether you substitute with like a u, we still have to face the age-old dilemma of, stink, how do I factor when there's a number in front? Multiply the first coefficient by the last constant. And we have to look for factors of, 6 times negative 6, what do we got? Negative 36. And you think about factors of negative 36 that add or subtract to be 5. Right? Nathan, I already saw you saying 4. Why are you saying 4? 9 and 4. Who's negative? Because somebody has to be, right? The 4 is negative because I need that 5 to be a positive. Positive 9 minus 4 is a positive 5. Now help me out. What do we use these to do? Split up the middle term and say, hey, I know where he came from. He came from, now some of you might prefer to put them in different orders. I'm just writing them strictly in the order that was put up here. Now what do I do? Group them, right? Now, does anybody see the one place we have to be super careful when we group, not to mess up?
-4.
The -4. Now the first one's pretty easy, right? We got that one. We still have to preserve with our grouping that it's not times. We're not making this magically multiplication of one times the other. It's not. It's an addition and subtraction. Sums and differences. But how do I still get that negative to go in with the 4? I can flip the negative or the subtraction to be addition of a negative. That's the one way to preserve. If I left that minus on the outside, I would mess up this poor little subtraction of 6. But if I change that subtraction of 4u to be addition of a negative 4u, he still has his negative like he should. He still has his negative attached like he should. Ricky.
Can't you just keep the negative and turn the 6 positive?
Or, that is the other option. Or you could have kept that minus sign on the outside. You could have started grouping and said, uh-oh, I pulled the negative out. I need to change that to an addition. Yeah, either way would be okay. Because if you guys notice, when we go to factor out what's in common, aren't we going to pull the negative out anyway? It's up to you as to which way to go. Now, what's in common between 6u squared and 9u? Hopefully you guys see 3u, right? What's left?
2 plus 3.
2u plus 3. Do you guys agree? How can we always quickly do a quick double check, a mental double check to make sure it makes sense? Distribute, right? Distribute means multiplying in. 6u squared, 9u, good. What comes out? -2. What's left?
2u plus 3.
Positive 2u. Careful. And
Plus 3.
plus 3. Now what do we do with grouping once we see there's a common, hopefully there is a common factor in both? Yeah. Take out that common factor. And then make a factor from what's remaining. Yeah?
And then would we put cosine back in? Would it be?
Now, some of you, you could do this process, and you could leave the cosine in the whole time. Now, I'm not going to do the whole process with the cosine in. But what's going to end up being my final answer, the final answer over here on the left-hand side? Instead of a u, what am I going to put? Instead of a u, what am I going to put?
Q cosine x.
Is the factoring in terms of u good? Yes. Is it done? No. One final step, I have to get back in terms of cosine. Whew, done, 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 done. Wait, simplify. Is there anything to plug in that would make it simpler? Are there any formulas for cosine? Adjacent over, don't go there. We're not going to triangles. Don't go there. In that table, any formulas for cosine? Oh, there's only one. Do you guys find it in the reciprocal category?
1 over.
1 over secant. Is that going to make anything nicer if we put 1 over?
No.
Yeah, we're done. We're done. See that one? The simplify was understood, but it's not going to help. Woo! Greek letters! Someone help me out. What is that weird B thing?
Beta.
Beta. Don't be scared. It's like an X. If you don't like it, you can always make it an X for your work. It's just a variable. Oh, stink. They don't tell me any math. They just say simplify. Well, they must think that I should be able to follow it without directions as to what math to do. What operations do you guys see up here?
Multiplication.
Multiplication, right here. of sine beta, remember that's all one thing, sine of beta, tangent of beta, sine times tangent. And what else do you see?
Addition.
Addition. Now can we do any of that right now? No. Because these aren't like terms, I can't add non-like terms, and how do you multiply sine and tangent? I don't know, just put them next to each other. Okay, it's already done. Struggle. Then we better go to our table and say, uh-oh, I bet there's something I can plug in to make things better. Maybe not better that you would see right away, but we have to do something. They didn't give us an impossible problem.
Quotient.
Quotient property, sure. Quotient property for who? Tangent. What's another way of writing tangent? Sine of, now if it's, yeah, we're going to put the beta in this one, but it was a u or an x in your table. Sine of beta over cosine of beta. A few of you guys get a little confused about the arguments. Remember, the argument goes with the trig function, so if I change to a formula, it has to go with each of those trig functions.
Do you mean tangent table?
Oh, I just said trig in general. Remember, the argument always goes with trig. X
got it.
needs to be in the sine or the cosine. So since the beta is in the tangent, it needs to be in the sine and cosine also. Remember my example. In a problem, you wouldn't just have a square root with nothing under. What's the point? Same thing here. We have to have those little arguments or else it's missing. It's empty. Now, is there any math we can do? We can put sine over 1, this sine, and say sine times sine is sine squared. Now, I know you're like, this is weird, but we're just figuring out what we can do to combine, to change the form, which mathematically I guess we call transform. Can we put those two together yet? No. Well, we kind of did the multiplication as best we could, but we still have to do addition, but we can't do addition unless we get a common denominator. Huh. Why? But he said to do something, and I'm doing the only thing I can figure out how to do. There was nothing to do until I started plugging in, and then, okay. What would I multiply top and bottom by to get a common denominator? Cosine. Remember, every time I say cosine, I mean cosine of whoever, whatever argument it has. Is that illegal to multiply something by 1? Cosine over cosine? Oh, that's good. Now what happens when we do that multiplication over there on the right? Cosine squared. All over. Now some of you might go ahead and combine this right away because you see it's common denominators. Others of you might leave it separate and then combine it in the next step, which we now legally can do, right? So my betas don't look like weird side-wackered hearts. Can we add sine squared plus cosine squared to make it 2 something? No. They're unlike terms. But wait! Property. Property alert. That should hopefully have little alarms going off saying, uh-oh. Sine squared plus cosine squared is? 1. If you don't believe me, go look at the Pythagorean property. Whew, we're done. Wait. No, we're not. Property. Now, here's the struggle. When do you stop?
Never stop.
Some of you might have stopped, some of you might have stopped, some of you might have hopefully not stopped. Try something. You have to be bold, you have to be confident. Be ready to make mistakes. Errors aren't terrors. I learned that one over break. Okay. But we come down here. What can we say? Woo! Look at that. No way! All that work took this big old 1, 2, 3 different trig functions, 1 multiplication, 1 addition, and the whole thing's just secret?
Why is that better than the top
On
one?
to chapter.
Why is it better?
Why?
In section 5.4, you're going to start seeing things like trig equations, and trig equations are going to have something extra like equals 3. Now, I made up one, and this might be illegal.
What the heck?
Wait,
What happened to your
wait,
Look at that.
better. Okay, how do you solve for beta? Hold on, come back. How do you solve for beta? But if you can get to here, how do you solve for beta? 1 over cosine is 2, cosine is 1/2, cosine is 1/2 at pi over 3, and maybe some more places too. That's possible, that's not. And if you can't make the connection, I drop my pen, but then I have to get it. Right? Okay. Now, hold on, that's not now, that's not yet, we have a lot of stuff in between. But someone did ask why. Okay, well, the good thing is they gave us the math to do. Oh, we can't multiply, there's subtraction in between. But we are going to have to do some multiplication to get common denominators, right? We can't multiply those two, but we do need to get both denominators to have the same expression. So, can we ignore the 46? What can we multiply top bottom by over here, and then multiply top bottom by over there? Okay, so multiply by the other one. We have to see these denominators as what they are, quantities. So I have this one, but I also need that one because I need them both together, and there's no other way without multiplying. Think of this as a 1/2 minus a 1/3. You can't make 3 and 2 the same unless we just multiply each of them by the other. Now, to be legal, I have to do the top and the bottom. I don't have an equals. I'm not moving to the other side. I'm staying right here. Multiply top and bottom. What am I going to multiply that one by?
+1.
The secant x plus 1, right? Fine. What do we do with fractions? Think PEMDAS. Don't ignore the subtraction. Multiply, and then we'll see if we can put together. What's secant minus 1 times 1? Is that okay? Huh. Whenever you have expressions like this, two trig expressions put together, or next to each other multiplied, you have two options. One is keep it factored and see if it cancels out, and the other is multiply it and maybe it'll do something.
Keep it back.
Keep it factored, see if it cancels out? Okay. Can I go ahead then and make my life a little easier and do 2 steps in one?
Yes.
Multiplying on the left, why am I combining it?
Because we want to combine it.
We have common denominators. But why was I careful to put parentheses around the second step?
So we don't know that it's a negative.
It's subtraction of the entire quantity, right? So I have to have the subtraction on the outside. Can I now distribute that subtraction if I want? I distribute that subtraction. Oh, I still have my denominator, right? We're keeping it factored just in case something cancels out. That would be awfully nice, I agree. Okay, what happens on top?
No, we don't get that.
These are both, right? Doesn't the subtraction distribute? I think those cancel. The secants. But what happens to the ones? Now, if you killed a seal, if you didn't distribute a negative, you'd be in trouble. But right now, a -1 minus a 1, -2. Uh-oh. Hold on, guys. With -2, are either of these going to cancel with the top? So if it's not working to keep them factored, maybe we should try doing what?
Stick it to the man.
Well, you could.
I agree with Ricky.
Now, no, this is a good point. Because you're like, oh, I'm done. There's nothing else to do. You could write that denominator, fine. And I would say, okay, good job. But remember how I said in the problem they don't tell you when to stop, so use the back of the book. Because you're going to go check the answer, it's going to be different. Why? They kept going. Well, I didn't know. Don't complain about it. Say, oh, You can keep going. Let me go see if I can get there too. Sound good? This is a section where the back of the book might not match your answer, but it's okay. You're just trying to say, oh, okay, there was more to be done. Let me see if I can do it too. Then come back to the problem. JJ.
Oh, never mind, guys.
Okay. So more to be done. What's more to be done? FOIL. Now, if you're super algebraic and trig doesn't scare you, you might say, ha, the difference of squares. What? I can square the first one. I can square the second one and put a minus. If trig scares you, or you're not very algebraic, you might need to do the first secant squared. Outer plus secant. Inner minus secant. Oh, they cancel. Last minus 1. But either way. Why is the back of the book so funny? What? I know, you can't see what the back of the book says. So let me go ahead and show you what the back of the book does have. Ready? The back of the book would have, hold on, -2 cotangent squared of x. What? Mine's not even close. Oh, you're one step away. You don't see it maybe, but you're only one step away. One step, that's all the room I've left. How? Go to your formulas. Keep your notes close in all this homework. It's not due until Friday. Keep your notes close. Go to your formulas. Is there a place with secant? Yes. 1 over cosine. Ew. I don't want to plug that in. Wait, secant squared. Secant squared minus 1. Is that a rearrangement of a property? Yeah. And if you need to look at it, the property is 1 plus tangent squared of u equals secant squared of u. Couldn't I subtract the 1? So I would have a rearrangement. Now some of you might need to write out each of these rearrangements so you can use them. That's okay, you just need to know that they're there. I can change secant squared of x minus 1 to be -2 over tangent squared of x. Why did I say just one step? What's over tangent? 1 over tangent is, now there's a 2, -2 is the coefficient. But 1 over tangent is cotangent. Tangent squared, cotangent squared. Dun, 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 dun. In this section, don't be scared of the back of the book. It's okay. I'm just going to tell you whether or not you got all the way, and if not, no problem. You're learning. You're going to try and keep going. We're going to be doing some math, like getting common denominators, but we're going to be using some properties at the same time. And if this step was a little too crazy, you could also look at it as squared just means squared. If you need that in-between step to help you for right now as you're getting used to this, the -2 is a coefficient I can kind of pull out to the side. 1 over tangent is who is being squared, and that is cotangent. Does that connect to cut pull the dots if you guys couldn't follow me? Is this kind of crazy?
Yes.
What makes it hard? Well, there's math. Simplifying common denominators with like ugly stuff like there's trig. And then there's these weird properties that can make everything way easier than it was to begin with. But that's okay, it's just an intro section, okay? So we're doing more examples tomorrow.
Yay.
Wait. Substitute and simplify, huh? Substitute and simplify, we still have 5 minutes, right? It's not travel day, that's tomorrow. Oh, these directions are like totally different. Hold on, what do we do now? Oh yeah, my clock's fast, isn't it? Is that what's going on?
Sure.
No. I came in after break, my computer clock is randomly 10 minutes fast. Sorry, that clock's fast. Maybe someone came in and was like, she's always late to meetings, who just said it? Just kidding. What are we supposed to do?
Substitute.
Too sad.
Wait, really? Just plug in? That's it?
Oh, good.
Huh. Okay. Well then, plug in. 9 minus who squared?
3 cosine squared.
Okay. I'm gonna give you 1 second. Just kidding. I'm gonna give you like 20. Do the squared and don't mess up. Go.
Like, can you use a calculator?
It would not.
You
can't do
any.
You don't need foiling.
Ooh, can't we put it into a graph and then get the equation?
I like that idea.
No, you don't have to do the entire thing. I'm just asking you to square. That's all.
Not 9 cosines.
Does the 3 stay or does it become a 9? That's my question.
Oh.
Oh, I've created so many of these and the 3 stays. Ah, what happens?
Oh, it's just because. Oh no.
They're both squared, right? What does square mean?
Oh.
Write it next to itself and multiply. What's 3 cosine times 3 cosine?
9 cosine.
Now, some of you would have gone straight here. Perfect. You were good. You didn't make the common mistake. But those of you that didn't or wouldn't have thought of squaring the 3, that's what I was trying to check out for. Or check for. Make sure we're okay.
Well, I thought you wanted to solve for.
Yeah. Are we done? No. Why not? Simplify. How?
Close enough.
Hold on. Anybody, an idea? What's something we can do? Subtract. No, they're not like.
Plug in your calculator.
Square root. Ah, you're killing the puppy. Oh no.
Split up.
Split up. How?
Into different.
No. Killing puppies. Puppy's dead.
Isn't the square root of mine?
Factor?
Yeah, that's what I said.
Is that what you meant? Not what you meant. If you were like, oh yay, it's 3 minus 3 cosine, you just killed a puppy. Remember, this would be 3 plus cosine times 3 minus cosine. That's not a perfect square. They're different. But what could we legally do while keeping our poor little puppies alive? Pull out a 9. That's legal. If I can change or somehow rearrange or transform to see multiplication, now I can split up. But that doesn't really help tons, because I can square root the 9, but can I square root the 1 minus cosine squared, or does he still have that nasty subtraction going on?
What about the other 9?
So I factored out both 9s, remember? So they came together. When you distribute, they're both there. I pulled out. Square root of 9 is 3. Square root is still there with the 1 minus cosine squared. I'm
I
stuck.
have a question.
Yeah.
Wait, so where'd that first 9 go?
Yeah.
Oh,
I factored them both out. Remember they're common?
wait.
Whoa.
And the square root of 9. I'm allowed to with multiplication.
Yeah,
I'm
that doesn't
allowed to
feel-
split that up and be the square root of 1 times the square root of the other.
This feels weird.
Okay.
I'm allowed to do that.
Okay.
Did anybody think to go to their table?
No.
I thought too, but I didn't actually go there.
What's 1 minus cosine squared? You wrote it a second ago in the rearrangement. Not secant, sine squared. Why was that good? There's no subtraction. I'm not going to kill puppies if I keep going. How can I keep going? Square root of the squared is... What? Now it's legal. There's no other weird subtraction messing me up. But there is one quick property out of math that says if you square root a squared, you actually have to maintain or keep the positive sign, S-I-G-N, the positive sign. So if you guys think about it, plug in a positive or a negative, square it, it's positive, square root it, it's positive, and it's positive. And there we go. Now guys, here's the crazy thing. Is this homework due tomorrow?
No.
No. Oh, there must be so many more examples left.
Oh.
Wait,
Thank you. No.
but I don't,
Are we doing
What?
homework tomorrow?
we're gonna have a couple warm-up examples. You guys are gonna work on homework.
Yay.
Then we're gonna see any questions to get on the boards to help out before we go home. Sound good?
Thank you.
Is it a good idea to start homework? Yeah.
No.
Is it crucial? Nah, use 3. Sound good?
Because it's so
Plus the hard section. We have a whole minute left, 45 seconds. No, don't go yet. You'll get me in trouble.
Nathan, you're never gonna get.
Stop, Mrs. Hill.
Nathan, you have 1 minute. Ready, set, go.
She's on the back side. You can stay with her for a while. Plus it's easy. She's a champ.
20 minutes.
She's a champ. She likes hedgehogs.
Wait, is this her?
Was it, hey, was it
This is her?
Caroline bought him a $25 suit.
Leave him alone.
Yeah, I bought him a better suit.
Alright, kiddos, stay alive, one more class until nutrition, wait until the bell, you can get ready towards the door, I'm gonna go sit down.
Spanish, no.
Spanish.